The drawer component by Emil Kowalski is a testament to the sheer difference between what makes a great engineer and what makes a good one. What makes a great engineer is not how to write code, it's by knowing what to build and by being exacting with your standards and not settling for less. And in this article, we see Emil Kowalski not settle for less on so many different occasions. Let's get into it. He first talks about building a drawer component and why he wanted to not use a modal because modals feel obtrusive and he wanted to have that native feel and look to the drawer component. They had a drawer component at Vercel, but he didn't want to go for it because didn't have drag to dismiss functionality and it had input issues. He used the dialog primitive from Radix and he used the similar API to Radix for people who are familiar. And now we get to the meat of the actual article. First, he started with the drag gesture, but he was facing slowdowns with the drag because he was using a CSS variable, and CSS variables are narratable, so that when he had more than 20 children in that container, it would start slowing down. So he fixed that by using an inline style instead. And then he moves on to using momentum-based dragging, and this is very cool to see. This adds an extra layer of physicality to the component. By using momentum, you can just flick it to dismiss it, and that's it. You don't have to drag all the way down. And here's the really cool thing again. He also damps the drag when you're moving up. So the drawer, instead of dismissing right away, instead of moving up and stopping suddenly, it dampens as if it's an actual spring. And this, again, adds physicality to it. When you have scrollable components inside a draggable component, that's when you start having problems. For example, you could be scrolling up to the top and you could drag it down accidentally and dismiss it. But we don't want that. That's why he added a timeout of 100 milliseconds when you're scrolling between between scroll and drag. And this is very cool to see. This is a nice detail that he added as well. He did a background animation. He animated the body tag and he scaled it down. Not only did he just scale it down, he also added the border radius to it. And here's the thing. They actually change based on the position of the drag you're in. So it feels like it's one cohesive gesture that works together. And that's very cool to see. Now, to mimic the springy motion used in the Ionic framework on Apple's native sheet component, he used this cubic Bezier easing function. Obviously with CSS we don't have access to spring animations, but we have access to tweens. And this is what he used. He tried to mimic it as much as possible. Now, this is the input. These are the input problems that previous drawer elements would usually have. Whenever you click on an input field on a mobile device, when the virtual keyboard shows up, the input field is pushed to be positioned at the top of the keyboard so that it's visible, of course. But here's the thing, that clips the stuff on the top of the drawer element, and that becomes unreachable and it becomes invisible for you. And he didn't want to have that. That's why he disabled the default browser behavior, and he opted to use the Visual Viewport API to resize the drawer. And not only resize it, he would also position the bottom of the drawer on top of the virtual keyboard. And that means you get a full access to a full drawer component even when your keyboard is open. And the only downside with that is that it's a jumpy animation. It doesn't have an animation actually jumps, but that's because he attached an event listener that listens for resize events, and that's how it works. It just fires one time and it changes it during the single time. He disabled multi-touch because he didn't want multiple fingers to jump between different points. Snap points or detents, these are checkpoints or various positions that the drawer checks to or snaps to. And he checks your current position and which snap point you're currently the closest to, and he snaps you to it. Not only that, he also added momentum here as well. So here you could actually skip over snap points and not just have a single snap point. You could skip over them and flick to dismiss it right away, or flick to swipe to the top right away if you have enough momentum. This is, oh my god, this is very cool. The final piece of our puzzle is the Safari theme bar. The Safari theme bar, he starts off by saying that CSS transitions and semi-transparent colors are not supported, and you can't use it in the meta tag for the theme. That's why he opted to use JavaScript and update it dynamically with JavaScript. First off, he starts off by getting the non-transparent color equivalent of the overlay color that's actually transparent because it's an overlay. So he got that non-transparent color equivalent, and he would start to update those values. And he calculated 50 steps. Each step takes 10 milliseconds, so that's 500 milliseconds, the full duration of the animation as he outlined here. Back in the motion section, yeah, there we go, 0.5 seconds or 500 milliseconds. So he calculated 50 steps, and he would animate them based on the drag gesture or the drag position, where you are in the drag. But here's the thing. This is a linear animation now. It doesn't have the custom easing curve that we have. And that's why he created this function to pre-calculate all the arrays of numbers that we could use during our drag positions. And this is very cool. You see this function? This calculates the step factor for each step based on the number of steps. And he goes through all steps and calls this other function right here. And the cool thing about this function is that if it's linear, it's going to do the factor normally. But if it's not, it's going to use this easing function. And this is what does the heavy lifting and does easing for us. And this is very cool. Now we have easing and we have the values, and the theme bar updates dynamically with our drag. And this is very cool to see. Yeah, he didn't even have to do that, but he opted to do it instead. And that's the really cool thing about it. That's truly what makes a great engineer. The final part, we actually realized that he didn't implement this in Vaul yet, because he's facing some problems with it, and he'll come back to it at some point. But yeah, it's cool nonetheless. And that's it.